Hello, everyone, and welcome back to our biochemistry lecture series on lipid chemistry. I am Dr. Muzammil Yaqut Ali, Assistant Professor of Biochemistry. Today, we are covering lecture number 2, that is the properties of triglycerides. This is a fundamental topic for understanding lipid chemistry, digestion, and food sciences. And if you find this lecture helpful, please like, share, and subscribe to our channel so you never miss the upcoming lectures. So let's begin. So, welcome to the second lecture on the properties of the triglycerols, commonly known as the tags or neutral fats. Today, we will explore both physical and chemical properties, along with the key analytic numbers used to identify fats and oils. So let's start with the physical properties. The general features. Neutral fats are colorless, odorless, and tasteless in pure form. The next one is the solubility. They are insoluble in water, but soluble in organic solvents like ether, chloroform, and benzene. So this is because tags or the triacylglycerols are nonpolar hydrophobic molecules. Melting point depends on the fatty acid composition. The rule number 1 for the melting point is the longer the carbon chain, the higher the melting point. And the more the double bonds, means the unsaturated molecule, that leads to the lowering of the melting point. So what about the examples? Saturated fats like butter are solid at room temperature, while the unsaturated fats like olive oil are liquid. This explains animal fats are mostly solid and plant oils are liquid in nature. So next is the specific gravity. All fats float in water because of their specific gravity that is less than 1. Now let's move to the emulsification. This is the breakdown of the large fat globules into tiny droplets. Why is this important? It increases the surface area for digestive enzymes, lipases. Bile salts help this process in our intestine. Now, let's move to the chemical properties of tags. Hydrolysis splits tags into glycerol and free fatty acids. This can happen with the superheated steam, acids or alkalis, enzyme like lipases. These are biological catalysts for the fat digestion. And the chemical properties we'll discuss in this lecture will be the hydrolysis, additive reactions, oxidation, and rancidity. Now let's move to the hydrolysis, right? Hydrolysis split tags into glycerol and free fatty acids. This can happen with the superheated steam, acid with alkalis. Alkaline hydrolysis is called as saponification, producing soap. And the enzyme like lipases, these are biological catalysts for fat digestion. So what about the additive reactions? Unsaturated fatty acids undergo addition reactions. The very first one is the hydrogenation. That means it adds hydrogen across double bonds. Liquid oils become solid fats. This is how banaspati dalda is made from cheap cottonseed oil. The next reaction is the halogenation. This means it adds halogens like iodine and bromine. This is the basis of the iodine number, which we will discuss later in this lecture. Next is the oxidation. Oxidation means highly unsaturated fats undergo auto-oxidation at double bonds, forming aldehydes, ketones, and resins. These are called drying oils, used in paints and varnishes. The next is the rancidity. This is an unpleasant odor or taste of the old fats. Two main causes are the hydrolytic rancidity and the oxidative rancidity. Hydrolytic rancidity means moisture plus heat release free fatty acids. And in case of oxidative rancidity, peroxides form and then break into smelly aldehydes. So, how to prevent the rancidity? Antioxidants like vitamin E, phenols, hydroquinone, and tannins can prevent the rancidity of the fats. So, how you identify the fats and oils? Sometimes we need to identify a pure fat, detect adulteration, determine fat proportion in a mixture. For this, we use three important numbers: saponification number, acid number, and iodine number. So let's discuss these numbers, right? The very first one is the saponification number. So let's start with the definition of saponification number, that the number of milligram of KOH, potassium hydroxide, required to saponify free and combined fatty acids in 1 gram of fat is called as saponification number. So what about its basis? Shorter chain fatty acids leads to more molecules per gram, have more molecules per gram, means more carboxylic groups are present in its structure. So that means the higher the saponification number. So butter is one of the example. Oleomargarine is one of the example, right? Oleomargarine that, with more long chain fatty acids have a saponification number that is around 195 or less than 195. So what about the acid number? So let's start with the definition, right? The number of milligram of potassium hydroxide required to neutralize the fatty acids in a gram of fat is known as the acid number. So what is its significance? It indicates degree of rancidity. Higher acid number means more free fatty acids from hydrolysis or the oxidation number are produced. So rancidity can be caused by the hydrolysis, means the presence of moisture and warm temperature bring about hydrolysis rapidly. And the second one is the oxidation of the double bonds of unsaturated glycerides may form peroxides, which then decompose to form aldehydes of objectionable odor and the taste. Next one is the iodine number. Iodine number is defined as the number of grams of iodine absorbed by 100 gram of fat. It measures the degree of unsaturation. Higher the iodine number means there will be more double bonds present in its structure. Example, the cottonseed oil, olive oil, linseed oil. So what about its application? The application of the iodine number. If olive oil has iodine number more than 88, it may be adulterated with the cottonseed oil. So this brings us to the end of this lecture on the properties of tags, the physical and chemical, both. So let's recap quickly. We covered physical properties like solubility, melting point, and emulsification. Then chemical properties including the hydrolysis, hydrogenation, oxidation, and rancidity. Finally, we learned how saponification number, acid number, and iodine numbers help to identify the fats and detect adulteration. If you find this lecture useful, please like the video, share it with your batchmates, and subscribe to our channel. And don't miss to hit the notification bell or the bell icon to get notified about the upcoming lectures. This is Dr. Muzammil Yaqut Ali signing off. See you in the next lecture. Thank you once again.